Okay. Don't know how this is going to work. My people, good morning. So today we're going to wrap up the multiple choice ideas and then start on an essay test, the FRQ portion that I'm going to hand out to you and that I've sent to our folks at home as well. So you can probably work with one of them today as well. We have at least theoretically Oscar and Amina that are out there somewhere. Okay. Last week we worked on the multiple choice questions. I'd like you to get that out one more time, along with, you have the key I gave you. If not, it's all right, I got it in my hand, so we can refer to it together. Not the bad key I gave you, but the key I did on this weekend and sent it out to you. So my question to you is, which ones would we like to ask about? So which ones did you maybe miss and you'd still like to know why you missed it? Of the 1 through 30 that we did. And Sophie. Mother. Well, I can only do one at a time. 16. Okay, let's turn everybody to 16. Louisa too. All right. Good. An arrow too? Oh my word, I got half the class at home. Okay. Okay. Sixteen says, oh, that's not 16. The best explanation for the lower pressure in the container in 4 is that SO2. Well, what's the right answer and why? What's the right answer and why? What's special about the SO2 that's a good guess that it's different than the other samples? The other samples are single atoms. SO2 is bigger. What's that going to make bigger? Look at the molar mass of that thing, 64. Yeah, it's you gotta be louder, Anthony. I'm sorry, but I can't hear squatting here with the fan and with this mask loud. Is it D or that I think we have? No. The type of bond has nothing to do with this. Nothing to do with this. Think back. Well, no. Exactly. So, in other words, Penelope, if it's stronger attractions, what will that do? What will that do to some of the molecules? They'll do what? They'll become closer and probably not hit the sides as much. And hitting the sides is what we call pressure. So if there's more intermolecular attractions, they're maybe touching each other more, and you just don't have enough of them hitting the sides to provide the pressure. So that's what it's all about. How do we know that? Because it's got the greatest of any of them in the chart. Anthony? Molar mass. And remember, bigger molecules or atoms have more electrons. We say they have a larger electron domain, and those electrons are more polarizable. And so you can have stronger either dipoles or in this case stronger London dispersion forces. So that's one of the intermolecular forces that Penelope mentioned. Okay, so stronger London dispersion forces will reduce the pressure. The particles will be closer together. They'll act more like a liquid and won't hit the sides as much. Okay, 17 you asked for as well. So let's go to the next page. And this goes back to potential energy diagrams that you and I did. Check this out. So we got 3 diatomic atoms, and there's the gap. Okay, skip down to the answers. What are the 3 different chemicals? They mix up the order, but it's essentially what do we got there, Aiden? All right. Already you can probably guess hydrogen's going to be which one? X2, right? Because it's pretty close to. Look at the x-axis, everybody. Internuclear distance. The distance between the 2 nuclei. Why is that going to be smallest for H2? Not a big surprise, because H2 is what? Entropy? The atoms are really small, exactly. So the internuclear distance is probably going to be small. Okay, for the other ones, you almost got to know this. O2 has what sort of bond between the atoms? Or N2 has what sort of bond between the atoms? Do you know either one? How do you memorize it, Lola? No, not between molecules, between the 2 atoms. Like what sort of bond connects N to N and O to O? Chelsea. Yeah, which one is which? Yeah, O2 has a double bond. What about N2? It's got a, let's see, triple bond. Probably that you should memorize. And it's not hard to memorize because check this out. On the periodic table, O2 lacks 2 electrons, so it's got a bond twice anyway. N2 lacks 3 electrons from a full shell, so it bonds 3 times, and that's a triple bond. So it's kind of what they have to do anyway. Okay, back to the diagram. The triple bond, it's really low energy. Which letters are going to be up in the graph? So it's going to be Y2. So a triple bond has very low potential energy. That's why they're really strong. Remember we said to get it out of this sort of potential energy, right, you got to put energy in. Man, for a triple bond, you got to put a lot of energy in. And so that alone tells you which one it is. Okay, if Y2 is the triple bond, then it's got to be AFS. Right, Y2 is N2. Other ones on the multiple choice that we would like to talk about. Alicia.
Number 8.
8, okay? Okay, so here we go. Pausing just to check this. No, I still have no Wi-Fi today. All right. So for 8, we got to do a little math here. Luckily, they make the numbers easy. This is multiple choice. So just like on Wednesday, you can't use a calculator on the multiple choice part. We'll come back, by the way, to the clausura on Wednesday so you understand it exactly how it's going to run. and so on. But let's do this one first. Here we go. So what's the identity of the metal chloride? Oh, let's look back and see. This is a little like the lab you guys did at the beginning of the year, where you did a precipitate of silver chloride, just like they did, and then you had to get it out there and dry it, and then weigh it the next day. So let's look at our data. Mass of the unknown, okay, but then once you got the stuff dried, then you got the mass of the filter plate paper plus the AgCl precipitate, and you got the mass of the filter paper. Well, we got to subtract what first off? Chelsea.
The mass of the filter paper.
Good. Mentally do that, Chelsea. 2.23 minus 0.8.
1.43.
Yeah. Now, what's she left with? It's 1.43 what? What is that then? Penelope? You got it. So it's grams of AgCl. What that means is we can change that sucker to moles. Okay? We need to figure out how many moles of that is. And look at the last line of the problem. The molar mass of AgCl is 142. You think that's luck? That's beautiful. So they give you 1.43. Okay, how many moles would that be? Can you guys do a little mental math for me? Instead of 143, if it's 1.43, it wouldn't be 1 mole, it would be how many? You got to be able to do this on Wednesday. So get the gears going. I know it's early, but it is for me too. Just, I think that's it. Let's work it out. When in doubt, everybody, just go backwards. 1 mole is 143. 0.1 moles would be 14.3. Just work it. 0.01 moles, what Chelsea gave us, is 1.43. Just go slowly and work your brain through it. So that's correct. Now, that stuff came from well, let's put it this way. The Cl came from what other chemical? It came from what other chemical, Lola? Yeah. And notice it's 1 to 1. So if I got the moles of AgCl, I've also got the moles of Cl minus, and I've also got the moles of M, or just MCl, yeah, M plus or MCl. So I got the amount of MCl on here, and yeah. Last step. We need to get the molar mass of this MCl stuff. What's the label? So A molar mass is just Han per Han anyway. Exactly. And what grams do they give us in the data for MCl, Aiden? There you go. And now we're going to take the number from Chelsea, 0.01 moles, and we got grams per moles. Ta-da! Okay, ready? Do a little mental math again. So now I've got to change this over, and it's going to become a bigger number, right? What bigger number is it going to become? How about, Elliot? 74. All right, then you look up the 4 possibilities and find their what? Find their molar masses. Which one did it turn out to be? Which one is 74? Okay, if you didn't do it, look it up and find it now. It's okay. I'll talk to my folks at home. Okay, so there is a microphone on here. Good. I'm sorry I got to use here. I'm sorry I have to use the school's computer. So I'll try and get this thing so you can see as much of the board as possible. Maybe I can put this on a chair. I'll try and write over here the rest of the time. Sorry about that, folks at home. Okay, and what is it, Enzo B? Again? Thank you. So it's case deal. So that's B. Now you might say, do they really want me to do all that? Yes, they do. Is this one you would do through the first time when you're working on multiple choice? No, I would mark this with a T and then just come back and try and do it the second pass through when you've got all the easy multiple choices answered, okay? Chelsea? Isn't a molar mass a KCl 74?
A little more, I think, it's like 75. I know.
Should be pretty close.
I see.
Yeah, you got 1K and 1Cl, add them together. Should be pretty close. Okay, other questions from you or other questions on the multiple choice? Ones that are still bugging you that we'd like to talk about. Anthony? 28, okay? So everybody turn to 28. For folks at home, I'll try and write where they can see now. And to be honest, Anthony, this is the one I really thought about the most. And I did it on Saturday. And I'm like, okay, I really got to think about it. So we've got these rate laws. And if you remember, rate laws kind of tell the story of what's important to have the chemical happen. So the rate is K times X2. So the Y2 doesn't seem to be very important. So it's only about the X2. That's the rate law, and that's given. So that's the way it really is. So now it says, here's two ways it could happen, two mechanisms. And are they both true or neither one true? All right, so I kind of went through it. I'm going to do it again with you. Let's look at the first one. For the rate law, we're mainly looking at the reactants. You know what I mean? The reactants, like what's reacting to make it. So for the first one, I've got my slow step is X2. And that works because with my rate law, X2 is the one that's first order there. And that's it. For the other steps, it's fast and fast, so I'm probably not so worried about it. Remember, a rate depends on the step, the Alicia? Rate determining step, which is the fastest or slowest one? Slowest one. So in these mechanisms, folks, key in on the slowest step with me. And so the fast ones don't really matter. So I think mechanism 1 works. Now, if you want to, you can also look and see, oh, it makes 2 X's and they cancel and the XY2 cancels and blah, blah, blah. It doesn't really matter. The important thing is the slow step is working. Let's take a mechanism 2. The slow step also starts with X2, just like in the rate law up above. So I think that sucker's going to work as well. I got 3 fast steps, but again, the X's all cancel. The other things, the intermediates, as we call them, all cancel out. So I think both work, though I think it's C. So I think it has to be C. Anthony? Yeah, I think you can. The time you can't disregard them is when the slow step is not the first one. Like if it looks like this, Anthony, if I have like fast, slow, fast, Often what that means is I'll have some stuff here, and this stuff comes from the one up above. And I gotta kind of go back and substitute stuff here in for something there in the slow step. We did that incident a couple times, but if it's just slow, fast, fast, really, the slow one is all you need anyway. And to be honest, in real chemistry, folks, usually the slowest step is the rate determining step. No, the first step is the slowest step. Not always, but most of the time anyway. So these are true to life mechanisms. Both of them have the slowest step as the first one. Good. Other questions from you on the multiple choice? Alicia.
11.
Yeah. Okay, let's go to 11. There's a couple of ways to do this. I'm going to tell you the way I do it. Actually, you know what? We haven't talked about that way. Let's just do it the standard way. Okay, for number 11, when 200 milliliters of 0.2 molar, or no, 2 molar, NaOH reacts with 500 milliliters of 1.0 molar HCl. Okay, the first thing you got to get is the for each chemical. The Feeny? Well, the molarity we've got, moles per liter. I think not the molarity, but just the what? The moles. So we've got to get the moles of each one. Let's do that. You can just change this mentally if you want, right? 0.2 liters times 2 moles per liter would be what?